Turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Greetings once again, ladies and gentlemen. This is Ernest with Retro Electro Tech. And on the bench today is a Sansui AUG99x integrated amplifier from around 1984 that came to me with an output complaint involving these relays kicking in and out. So I powered it up and noted flickering of the protection indicator, which is located on the front of the unit, of course, and which is normal during the delay between power up and activation of the relays. However, the protection indicator, continued flickering and all that in response to the relays behaving erratically, dropping in and out. As such, I went straight to the speaker out circuit board here. Before I pulled it, of course, and with my new and improved Retro Electro Tech Fancy Pants pointer probe, I began to carefully, flex the board just slightly in various spots and was able to kind of hone in on that sweet spot that induced the same relay behavior. That being the case, once I got the board out, as you can see here, and safely discharged capacitors, especially these Mongo caps down here, let me get panned back up. Which was actually hindering the removal of this board to begin with. So, once I got that out, I was able to inspect solder joints and probe at components more effectively, and which resulted in the discovery of this. Let me get these in here. Okay, so as you can clearly see, this transistor is all loose and jiggly, like Polynesian hula hips, only without the... So, this transistor I just showed you, labeled Q1 on the board, along with this one here. We'll just call these transistor 1, transistor 2, are connected in a Darlington configuration, which in conjunction, of course, with all the other components that make up this protection circuit, is what operates or drives these relays. I did ascertain from the customer that he is the original owner and has never messed around inside this unit. However, I was told someone worked on what I believe was the same issue or something similar. Now, I have no way of knowing if the previous individual that was in here caused the issue that I've mentioned, as well as a few other things I'm going to point out in just a moment. Or, perhaps the individual who was in here just simply overlooked what I have now discovered. So anyways, what it really comes down to is this. Although I've conducted a preliminary or cursory inspection, I do need to go through this amp in more detail and inspect everything further. And just even with my cursory, I've already found yet another TO220 package transistor flapping in the wind on this board here. All right, so let me get some light back in here. Hopefully I'm not going to cause too much glare. But anyways, here's the board I'm talking about in here, and here's the transistor, that other loose transistor, the TO220 package I was talking about, same as on the relay board there. So anyways, why two in a row? Who's to say, but it is, so it's going to have to be dealt with. I'm going to have to pull the board out, and of course, while I have it out to resolve that, I'm going to check the solder joints and traces and all the additional components on the board and make sure everything is all right beyond this loose transistor that I wanted to point out to the customer. Now, access is pretty limited in here. There's circuit boards stacked in here, wiring, even the pots and the switches are, they're soldered to circuit boards, there's stuff stacked on top. Accessibility is limited, so if I had to go in here, and it's limited in a few other parts of the amp too, that would involve, extracting boards in other parts of the amp and so forth, which of course equates to, more time and expense. But so that would be the case if I had to get in here. There would be, a fair amount of disassembly. So that's just something that might need to be considered if there's other issues found. I'm hoping that my detailed inspection as I continue along, won't reveal anything beyond what I've already uncovered. So let's just hope for that. And, you know, the owner was using this, and other than the issue with the relays dropping out, I think everything else is fine. So that leads me to believe that once, you know, those transistors and perhaps any other loose components that I find, you know, once properly soldered to their boards, and, you know, and I touch up any accessible solder joints that look suspect or whatever the case, that everything should function as it should. So that's the hope. And so that being said, let's just go ahead and move on. Okay, since the issue with this amp appears to stem mostly from the speaker output board, you know, I'm going to focus a little more testing and attention toward all these components, you know, caps, resistors, the diodes, including the clamping diodes across the relay coils, etc. And of course, you know, if other issues become evident, you know, anywhere in this amp, you know, I'll address those as well if everything remains within budget, of course, and the customer wants to proceed. The last thing that I want to point out for the customer is that someone who had their hands in here was kind of wheeling and dealing in a heavy-handed manner, as is evident by these scratches that I'm going to show you on these circuit boards. Okay, now here's the back of the relay board, and it may be difficult to see the scratches, you know, the way that I'm seeing them over here on my side of the world, and it may have to do with the angle of the board as well, and also to the fact that when I zoom in this camera, it does get a little more fuzzy, and so there's some detail lacking there. So I'm going to reach over the camera. I'm kind of in an odd position and point out what I'm talking about. There's scratches all in this area here. So somebody was in here and being a little bit heavy-handed, and you know, that's something when I'm doing my forensic analysis, if you will. You know, I pay attention to that because, you know, it tells a story. It sort of, you know, paints a profile of, you know, who was in here and what type of care was taken or lack thereof when they were in here manipulating things around. So hopefully you can see what I'm talking about. Also, too, I wanted to mention it to the customer because now that my hands have been in here, I want the customer to understand that this was, you know, pre-existing, these, you know, these scratches on here. So anyways, let me also change my angle because I have something else I need to point out. Okay, so here we are at the back of the main amp board, and well, you know, as you can see, there's a lot of scratching. It's like they were having an electronics fun day at the insane asylum, and good old Dr. Demento cut loose the lobotomy twins on this thing with a couple of wire brushes and told them to go scrape their way to Japan. Quite a bit of scratching, like I said. So I just wanted to bring this out once again because my hands have been in here, and you know, obviously we know there are better ways to clean contact points without scraping the crap out of board surfaces. So again, I just wanted to point it out, and moving on. So the last time you saw this board, it was component side up. Obviously, we're looking at all the solder joints and traces and all that, and our loose and jiggly, I believe it's a 2SD357 NPN power transistor, is right here where these three leads are located. Okay, so let me go ahead and get the desoldering iron in there and get that out of there real quick. Okay, let's get this transistor out of here and ready for testing. Okay, here we go. Okay, as mentioned, I'll be testing everything on the speaker output board, some components in circuit and some out of circuit as needed, you know, based on in-circuit results. And what I'm trying to say is if I receive a suspect reading during in-circuit testing, I'll pull the component that I'm testing from the circuit for more of a definitive reading, which is always best, especially to help confirm any anomalous or otherwise funky looking readings. So let's jump in with some down and dirty testing that will provide some more than adequate data which we'll use to judge component performance and overall health and see what stays and what goes. So we'll start with the 2SD 357 transistor down here where the pointer is. As you can see, I have it hooked up to the tester. I do calibrate it between every use. I've been inside this little meter here and have done work to achieve you know, the best accuracy possible. You know, I do calibrate everything and I do go through everything and make sure all components are within spec, especially you know, with test equipment. So something like this is more than adequate to give us the results that we need to make a judgment on this transistor. You know, I'm more than confident that the results that this returns is just fine and well within the ballpark, even considerably narrower in many cases. So no problem there, considering, you know, we're not working on any advanced avionics for the space program. So this will be fine. The type of testing we're going to do in general, not just with this tester, will be fine for this Sansui AUG99x integrated amplifier. In regard to calibration, the transistor here under test is going to be put into a calibration mode. Again, it's an NPN power transistor, so let me switch it on over to NPN. You're going to see the needle rise up to this calibration line here. Okay, and it's pretty darn close. So I'm going to step on in and bump the calibration knob just a little bit to try to set that needle right over the calibration line, and there it is. I'm going to press this test button here. You always start out in ×1. However, I'm sure it's going to exceed 50, which is the criteria in which you need to use ×10. Anything over 50. So let me go ahead and switch it to ×10 and do that again. Okay, and our gain is right about 180, which for this transistor we have a minimum of 55, maximum of 300. So I'm happy with that. I can live with that. And now I'm going to check our collector to emitter leakage here on this microamp scale down here in red, and that should be just nice and low like it is. You know, the lower the better there. And our collector to base leakage, same thing, nice and low. Okay, so I'm going to continue with a little more transistor testing off camera so I can speed up the process here in the interest of time. Okay, here I am starting to test electrolytics, starting with this, well, there's several caps on the underside of this board, and starting with this 16 volt 100 mic cap, we're going to kind of get this show on the road here, and hope that we get some good results with in-circuit testing on the rest of them as well. And like I've said before, if any of them show any anomalous readings or whatever the case, they will be pulled from circuit and more definitive testing will be done to verify whether they're good or bad. But again, here we go. Let's just fire this up, let it go through its... Okay, and on that cap we're showing 115.6 mics at 0.12 ohms of ESR, and that's within a nice range there, not a problem. So I think we're off to a good start if we can continue with that trend. And anyways, continuing on. Okay, I'm also going through and checking resistance values, and you know, everything happens fast on camera. You know, it cuts out and then we're on to something, but you know, trust me, I'm going through all these components, I'm checking all the values and just sussing out everything on that board, make sure everything's looking good. Now, this isn't really about going through and testing all of the components and so forth on camera. That would be really unenjoyable for anybody who had to watch that for any length of time. This is just kind of showing the process that I'm going through, within the time allotted, within the budget. As I mentioned previously, and I'll mention again, I'm going to be giving this board more attention because most of the problem appears to exist here. So again, the signal was lost at this board. It returns when I flex the board as the relays, engage and drop out. Additionally, that very loose TSD 357 power transistor was discovered jiggling around on this board as well. Again, it makes sense to devote a little more time to this speaker output board. Not to mention, I have continued forward with my hunt for loose or otherwise compromised components and connections. And so far, things are looking all right within the accessible areas of this amp, that I could feel around in, probe around in, and, get some light into. I'm going to start working on that last board in just a second, where that other loose TO220 package transistor is located. And this board was actually kind of tough to get out, because there was these plastic standoffs that have these clips that you have to press in and snap them. You snap the board down onto them and all that. So that was real fun reaching in there and dealing with those. But anyways, it's done. So as you can see here, this transistor, you just barely touch this thing. It's super loose. And let me flip this on over and see if I could zoom this camera in here. Look at those leads. So anyways, yeah, let me kind of pan back out here, and anyways, in closing, I had to make the best use of my time and testing to stay within budget, get the primary issue or issues in this case, resolved, and just do the best I could to hunt down any additional trouble. So it looks like we're heading in the right direction at least, so stay tuned for the final testing and any info concerning any additional findings if applicable.
This is a poor man's shoe production.